This lecture 2 of the subject integral calculus. And in this topic, we are going to discuss integration by substitution. Many antiderivatives cannot be found directly by applying formulas. That is when you have complicated functions. Eh, However, sometimes it is possible to find an antiderivative by the formulas after changing the variables. So from complicated functions, whether it's algebraic function, logarithmic, exponential, or trigonometric functions, okay, you can simplify it by changing the variables so that it will fit the basic formulas. So, therefore, the main problem in evaluating an integral lies in expressing the integrand in the standard form. Highlighted, oh? Okay, so this is our objective, to be able to express the integrand in the standard form para ma-fit na lang eh. So for this purpose, we may have to use algebraic operations, okay, and or trigonometric identities for trigonometric functions. Yeah. So, you will use this one para ma-simplify nimo from complicated functions to standard form. For certain integrals, we may have to change the variable of integration by using the method of substitution. So, we will change the variable of integration. And normally, the variable to be used or to be substituted is u. So you replace x by u. But you can use other letters like v or any other letter. But the normal one or commonly used substitution, commonly used letter to substitute is u. So in such cases, the element of integration is changed to a new element of integration. So the new element, uh, itong u, no? In which the integrand, which is in a new variable, may be in the standard form. So after changing the variable, the integrand could be in the standard form. Na? So you'll just fit it to the basic formulas. And once the integrand is expressed in the standard form, evaluating the integral depends only on recognizing the form and remembering the table of integrals. So the easiest part na once you'll be able to express the integrand in the standard form, all you have to do is recognize the form or remember the table of integrals para ma-fit nimo, and then you can find the antiderivative. Thus, integration as such is not at all difficult. Not at all difficult once ma-express nimo, once you can express the integrand in the standard form. Uh, But before, along the way, it's a process of expressing the integrand in standard form. That's the difficult part there. But once ma-express na, or once it is already in standard form, it is no longer difficult. Okay. So with this statement, some of you might have this expression, eh? Or this one, or this one, and lastly this one, nosebleed na. Okay. Because with this statement, some of you might not agree with this. So the real difficulty lies in applying the necessary algebraic operations and using trigonometric identities needed for converting the integrand to standard form. So you try to familiarize or remember this, that the real difficulty lies in applying the necessary algebraic expressions and trigonometric identities to convert the integrand to standard form. Okay. And in this part, experience will come in. With your experience solving many problems, then it would sometimes it could be easier for you to convert the integrand to standard form. Okay, let us have some sample problems. First, evaluate the integral of t times quantity 5 plus 3t squared raised to the power of 8 dt. Okay. Now, in evaluating this integral, of course, you're going to change the variable. But if you try to remember functions raised to a certain power, you will always remember the power rule. Ba? So therefore, uh, this expression 5 plus 3t squared, you are going to replace this one by u so that you will have u raised to 8. And probably, you will realize that you can use power rule later. So that would be our substitution. Let u be equal to 5 plus 3t squared. Okay. So we have this one, u equal to 5 plus 3t squared, and then differentiate. Because since t is already replaced by u, then we have to replace dt by du. So you differentiate this one, derivative of a constant is 0. Derivative of 3t squared using the power formula, and it's 60 dt now. So we have t and then dt. So that's okay. And therefore, first we have to rearrange this one para ma-fit siya. Okay. So let's rearrange and we have this. Okay. And then we are now ready to change the variable. Okay. So this 5 plus 3t squared, we're going to replace it by u. So we have u raised to 8. And then t dt, we will replace it by this one. To solve for t dt, yeah, we have du over 6. Oh, and we have this. And then first property of anti-differentiation, if you have this constant, you can place it before the integral. So we have this one. 1 over 6 integral of u raised to 8 du. And using the power rule, this one, and then okay, 8 plus 1, 9, 1 over 54, 9 times 6, 1 over 54. And then your final answer is replace u by the original expression or variable. 5 plus 3t squared. So you have this. So again, if you recall the statements before I discussed a while ago, our objective is to express the integrand in standard form or to convert it to standard form. That is why we substituted this variable u sa 5 plus 3t squared na ni kamaptan u raised to 8b. Okay. So, and once ma fit sa standard form, it is no longer difficult now to find the antiderivative or the integral. Okay. Sample number 2. Evaluate the integral of square root of 3 minus x times x squared dx. So, uh, if you encounter this problem or type of this problem, sometimes it's normal to make the integrand, I mean the radicand, sorry, make the radicand as your u. 3 minus x to be replaced by u so that you have square root of u, or if you want to convert it to exponential form, you have u raised to 1 half, square root of u, or u raised to 1 half. So let's try now. So u will be equal to 3 minus x and du equals negative x squared. So 3 minus x replaced by u, dx, we can replace it by negative du. So our problem now is how about x squared? So to determine x squared, we make use of this. We solve for x, which is 3 minus u, and then square na to. 3 minus u squared. And so we are now ready to substitute or replace x by u. We have this one, dx equal to negative du. So let's replace it. Square root of 3 minus x, or u, x squared, this one, and then dx, this one, negative du. And then expand this binomial. And then from integral form to exponential form, and then expansion, and then distribute u raised to 1 half, like this one. Of course, considering negative. Negative times 9 times u raised to 1 half. U raised to 1 half times u. You just add exponents. 1 half plus 1, you have 3 halves. 1 half plus 2, you have 5 halves. And the signs are changed because of the negative sign. So from positive to negative, negative becomes positive. Positive becomes negative. And you can use the power rule combined with the constant rule, like this one. So negative 9, integral of u raised to 1 half plus 1. Okay? Step 1 is just add 1 to the power. So 1 half plus 1, 3 halves. And then divide the term by the new power, 3 halves. And also the second term and the third term, plus constant of integration. And then you simplify, like 9 divided by 3 halves, and then you replace u by 3 minus x, and you have this. 9 over 3 halves is 6, and then u raised to 3 halves. 6 divided by 5 halves, you have 12 over 5. And then reciprocal of 7 halves is 2 over 7. Okay. Example number 3. Again, as I have said sa first sample problem, if you have this expression raised to a certain power, most likely, you will make this one as your u, so that you will have u raised to 1/4. So let u equal to x cubed plus 3, and dx 3x squared dx. Now, we have x raised to 5 and we only have x squared. Ba? So, we still have x cubed. Ba? So, okay. If we will rearrange or simplify, x raised to 5, we just break it to x cubed and x squared. No? So that x squared dx is du over 3. Just divide 3. Oh. So this is du over 3, and this is u raised to 1 over 4 x cube ang problem. But from this one, we can solve for x cube. And that is u minus 3. And so we're going to substitute this one here. Okay. So solving for x squared dx is du over 3. So, and then let's substitute. U raised to 1 fourth and x cubed replaced by u minus 3. This one. And then x squared dx replaced by du over 3. And then first property of anti-differentiation, constant may be placed before the before the integral. Okay, so 1/3 and then u raised to 1/4 distribute 1/4 plus 1 5 over 4 and this and then use power rule. So 1/3 integral of u raised to 5 over 4 plus 1. That's 9 over 4 over 9 over 4 minus. Of course, you have 1/3 and then 3. And then 1/4 plus 1. That's 5 over 4 over 5 over 4. And then simplify the coefficient. 1/3 divided by 9 over 4. And then 1/3 times 3 divided by 5 over 4. And replace u by x cubed plus 3. And this is your final answer. Next, evaluate dx over x ln x. Okay. Now, in this one, in this problem, you might think that the denominator, all of this one will be replaced by u. But sometimes this requires experience or trial and error, no? So that once you differentiate u, you will have your du. Okay. So you can let u equal to x ln x, or you can let u be equal to x, or u equal to ln x. And then later, you will realize na all of the three options, x ln x, and ln x, out of the three, you'll find out or you will realize na the correct one is ln x. Oh, u is equal to ln x. So that when you differentiate, you have 1 over x dx. So dx over x is du. Because if you use x ln x as your u, you're going to use the product formula sa differentiation. Ba? So complicated na. Okay. And also, if you will use x, u equal to x, du is just dx. How are we going to change ln x? So wala ba? Nothing will happen. So therefore, our u is ln x. And du is 1 over x dx. So dx over x, that would be our du. And then ang ln x is u. So this becomes du over u. And logarithmic form is just ln. ln of u plus c. And then you replace u by ln x. Now take note, ln you'll use absolute value because oh, if this is negative, it's undefined. So therefore, this must be positive. ln of a negative number is undefined. So we have to use absolute value. Number 5. Evaluate ln squared 3x over x dx. Okay. Now, if you are confused with this, ln squared 3x, this is just ln 3x raised to the power of 2. Uh, but when you write this one, it's ln squared 3x. It's the same as cosine squared theta. It's actually cosine theta quantity squared. Uh, because when you use your calculator, you cannot input cosine squared 30. Uh, it should be cosine 30 and then square the answer. Cosine 30, that's point 0.866. You square that one. Uh, but when you write it, it's cosine squared theta. Same also with this. ln squared 3x is the same as quantity ln 3x niya squared. So, from example form, you already have an idea that if your u is ln of x, the derivative in the du will have dx over x. So, this dx over x, that will be your u. I mean du. So, therefore, ang your u will be ln 3x. Ano? So, this is the meaning of this one. ln of 3x quantity squared. So this would be our u. Let u equal to ln 3x. Derivative sa u, of course, ln 3x is 1 over 3x times derivative of 3x, 3 dx. Okay. So just review your basic derivatives. So cancelled, and therefore du is dx over x. So ln 3x is u squared, dx over x is du. And this is basic power rule. So u cube over 3 plus c, and then just replace u by ln 3x. So therefore, for the 5 sample problems, you have an idea that the difficult part is uh, what function you're going to replace ba, para so that you can convert the integrand to standard form. And sometimes it will require trial and error na process. Like this one. Okay, it's a product of two functions man, x and ln x. So trial and error whether let your u is x ln x or simply ln x. So 3 trials, and then you try to fit which of those substitutions will result to a simpler function. Okay, so thank you for watching. I hope that you have learned something from this presentation.